So welcome everyone. I'm Cris and I have here my partner in crime, Gavin Parrish. This is our monthly Exadata office hours. And today we have Jeff Wright, who is an expert on a bunch of Exadata Cloud stuff, especially lately on Exadata Cloud customer security. We put a document up that contains the technical details. The point of having some background like that is to enable Jeff to speak more informally, knowing that you can go and refer to the document. So I'll let Gavin give his complimentary intro, and then Jeff tell us a couple of minutes about himself.
Yeah, security is something that I've been interested in a very long time. But more recently, the idea of cloud, and as people move into this kind of shared infrastructure point of view, my previous role was with the cloud customer team. So working with customers and identifying issues that stop them moving into the cloud 100% or moving their core systems. And Jeff was part of the team on the other side of the fence and really came through as somebody to dig into the security details and really work with the customer. So I'm happy you're here, Jeff. It's going to be fun. You can go as deep as you want, and hopefully we've got some questions. But yeah, it's an interesting area. The security and breaches are talked about a lot when they're publicized, but probably more that we don't see. Yeah, it's a complex topic. So that's my complimentary spiel. Jeff, why don't you just tell us about yourself?
Sure. I appreciate the intro and the invite. So for the folks that I haven't met, I work in the Exadata product management organization. The niche that I found for myself is cloud for banks. And so the interesting part of my career over the last 3 years, and Oracle brought me in, they indicated, hey, do something with security with Exadata, which, was kind of like, I don't really know what that is. And over that had become a partnership with a host of regulated customers. The bit that really came out was that, security, like in terms of a word, right? That's a feeling. It's something that we like to say when we're safe and secure. And it's something that when we don't feel good, right, we say we're insecure, it's not safe. But over the last 3 years, working with a bunch of banks, a handful of energy companies, and some defense folks, the thing I really learned about were controls. And the exercise is about how do you make a computing system that permits authorized things to happen. You want the good stuff to happen, right? But you also want to make it so the computer system prohibits unauthorized things from happening. And ideally, we want to do that with technology. The bit, right, if we imagine, what is the most secure computer? The most secure computer is turned off. It is not plugged into anything. It's running no instructions. And it's locked in a very, very sturdy vault. Your data is secure when that happens. If you turn the computer on, your data becomes accessible. And by definition, it becomes less secure. And the exercise with these financial services customers in particular is that we understand for things to be useful, we have to provide access. And then we learn that when we provide access, we have a risk of unauthorized access or any unauthorized action for that matter. We have to turn the computer on to be useful. The next most secure system is one that's only running authorized software, preferably one that's running software that doesn't have any known security vulnerabilities. And if you're only running authorized software and no human can log into the computer becomes useful and a lot safer. The next step is when you allow a human to interact with the computer, it by design becomes less safe, right? Because a human has intent, we can do things that we're not supposed to do. And the really interesting part of the exercise is how do you open up the computer to humans enough for it to be useful, but not so much that it causes an undue risk. And so, yeah, this whole exercise of security has really been around software controls. And that's been the majority of what I've done so far with Exadata and Exadata Cloud Customer.
Oh, that's a wonderful conceptual framework. That's great. That connects why you talk about controls all the way up to the top level requirements. I have a couple of questions. The first question is, I know we are all good and everything, but can Oracle access data?
Yeah, absolutely. That's a really great question. So if you're a If you're in a co-managed service and you draw a picture of a vendor that's accessing a computing system, and then you draw a picture of the customer who's accessing a computing system, and we'll do a little picture. So I'm not going to go through the deck, but I did want to bring up a couple pictures because they're interesting to talk to. When you ask the question, can something happen with a computer? The answer is always yes. There's always the possibility of a software defect that exposes an opportunity for an attacker to run arbitrary code. The more useful question is to describe what are the controls in the system that govern how you can access data, and then show that those controls are the things that are in place. And if you believe that those controls are sufficient, then you can say, great, this computing system is fine for me to use for controlling access to the data, versus no, this isn't safe enough. When we do the Exadata Cloud at customer system, there's three major bits that we have in the system. We look at protecting the data. So the first thing is you have Oracle stuff here as the things that are shown in red inside of the infrastructure. And there's a couple of main access vectors, right? If you're on the infrastructure DOM 0, you can look at the network packets coming in and out of the virtual machine. You can look at the network packets that traverse the InfiniBand switch. And then you can look at the network packets that come into the storage server and anything that's stored on the storage server. So that the first set of controls in the system is that we run SQLnet or Oracle Native Network Encryption on the client application, so that any inspection of the packets, which is 100% possible in the architecture, only shows you encrypted data. And then once we write the data out to physical storage, or in the Exadata storage server, we encrypt that with transparent data encryption. So if you observe the network packets from a physical database server, or you look at the storage devices that are inside of that database, all that you see is encrypted data. And so the first set of controls are that we use encryption to make it so that unless you have a customer credential and you're logged into the database, you can't see the data, you only see encrypted data. So while it's true Oracle can access data in the system, it's the encryption that protects it. Your next question usually is, what happens if Oracle staff access the customer VM? The next question you might ask is, can an Oracle person gain access to the customer VM?
Well, yeah, that was the underlying question, exactly.
Yeah.
How much should I trust whom?
Yeah. I think the first bit is that you should trust the software to run as it's been coded. That is something we have to trust. We have to know that the software is coded to perform a specific thing, and the software will run as coded. You want to make sure it's coded to do what you want it to do, and that's quality and testing. You shouldn't trust an Oracle person. You actually shouldn't trust any person, right? Because the important part about people is we have intent. And what we really want to do is make controls in the system that if people are doing the job they're supposed to be doing, like life is good, and you want to make sure that you have people that are good, but because you can't always protect against the possibility of somebody deciding to do a job that they're not necessarily chartered to do, you shouldn't ever trust people 100%. The mechanics in the system is that Oracle software can access customer services. So when we draw a picture of how the service looks, and you are a customer, which is this person up here, you have access into databases that run inside of a virtual machine. It is true that Oracle software will access the customer virtual machine on a particular kind of connection, MTLS secured connection into a database agent. And it is also true that some parts of the Oracle software will access that same virtual machine using an SSH connection on port 22. When you think about the controls that are in the system, there's controls in the system within Oracle that secure and protect access to the credentials that are used to access the VM. So there's a credential, MTLS authentication, to connect to the agent. And there's the credential, which is an SSH token that you use to connect into the VM. Both of those credentials are checked inside of that customer VM. Those credentials are your first line of defense. They provide a good, solid mechanism for protection. And if you're comfortable with the credential security, everything is good. The next aspect is if you decide that you want further control, meaning I'd like to protect isolated a network layer, as a customer, you can always block the connection into the agent so that the agent can't connect on 443. You can always block the connection on port 22, which means you can't connect through SSH. And of course, blocking connections makes the service less convenient to use because the agent won't work, right? You can't create a database, for example. However, it does offer you a balance of security. And so the thing when you look at, can something access the data, what we really want to say is that the controls that protect the authentication of the software is the first layer. And if that's not enough, you always have the protection as a customer to block that port access.
And is it a reasonable thing to say that there is a different class of access, for example, for configuration than there is for regular use on a given configuration? And in the latter case, you might be able to maintain things working, but tighten the security by blocking those accesses, for example?
Yes, that's actually a very common thing. Sometimes you have the idea of periodic maintenance where you have an authorized time window where you can change a computer. Going back to, can you connect to a computer? You know, if only software connects to it, that's one level. If people connect to it, that is a higher level of risk. When you think about secure runtime mode, a customer may say, I want no possible connection to my virtual machine or my database, except the SQLnet connections on port 21, possibly an SSH connection from a very specific initiator. Those kind of customers will erect a firewall to block layers 3 and 4 so that there's no mechanism to connect to processes or ports inside of that VM at all, except for permitted software like SQLnet on 1521. The bad news in secure runtime mode is you can't change anything. But the good news in secure runtime mode is you can't change anything either, which also means that your access vectors are far more secure. So kind of the trick there is, you know, if you're in a dev environment and you're changing things all the time, you might not put critical data in it. You might tolerate the risk of unauthorized access because the assets that are inside of that VM are not very valuable. And the value of fast access to that VM is that you get to market quicker. Once you know what you're doing, you might entrust high value assets to that VM, at which point you would lower the risk that something unauthorized could happen by cutting all the wires that go into that via something standard like a firewall. And then once all the wires are cut, the system becomes inconvenient to use. However, if you don't need to patch, then you don't need to worry about that inconvenience. So it becomes a really nice balance to decide from a control and risk perspective what's required based on the value of the assets that that VM manages. And then of course, you know, what we're describing is in addition to the controls in that VM, we also have the data in and out of the VM as encrypted. So you get this really nice picture. When the data is exposed to this stuff in red, where Oracle staff can operate, the data is all protected by encryption. The mechanism to get to the keys is you have to get inside of this thing here in blue, which you can log into the database. That you can further lock down with the firewall. And then of course, the last thing, if you're really in the business of doing this right, the picture that we draw out, we do this little build out slide. You know, here we show all the gray stuff that Oracle staff manage and operate. And then we know customers run inside of this VM. So this VM is the thing that we block access to with this firewall, which gives you a layer of security. You have a database that's encrypted with transparent data encryption. That's what protects it when it moves through the infrastructure. The next bit is that you can take that TDE encryption key, completely remove the master encryption key from the infrastructure and store it in a completely separate location like Oracle Key Vault or any third-party HSM. So when you talk about really locking this thing down, that control removes the key from the infrastructure, providing you another layer of isolation. And then when you walk up, you put your client and backup network on the thing. Your DBA and SA can get in and access the VMs in the database. We use Oracle Database Vault so that we can revoke the system or privileged accounts from having access to data to give yet another control. So at this point, you only have named user access to data. And then your apps that are going to do named user access to the data, you could surround your database with something like database firewall. So that will explicitly control the SQL connections that come in and out of the system. And of course, other types of things get accessed on the system like test and dev. And then we can further control access to data through redaction, masking, and subsetting. So now named users access data, but they can only see data specific to the roles and jobs that they have. And so in that model, you have a really solid set of preventative technical controls that are layered on. Redaction, masking, and subsetting control what a specific named credential has access to. Database vault makes it so that privileged system accounts can't be used to access the data. The encryption on the system is what makes it so the data is not accessible when you go to the infrastructure to look at it. The firewalls that you surround the virtual machine by and the authentication controls on the virtual machine are what prevent Oracle staff from gaining access to those virtual machines. And then finally, the migration of the keys to an external key store is like another layer of isolation and protection.
So, Jeff, how much of this is out of the box, and how much does a customer need to, tinker around and play with to make sure that they are secure? What is there, and what additional bits does a customer need to do? That's
a great question. A couple of bits. The first one is that out of the box, the first thing you have to do is to change the root password. So we create a secure root password for the VM, customer VM, that comes with the cloud. It's a randomly generated password. The first thing you have to do is change it. And that's usually a customer logs into the system and changes that root password. The second thing is that the Exadata itself is very hardened. It's a minimum distribution. It's not likely that you'll remove software from the Exadata operating system image to make it more secure. Oracle's already removed all of that. The next step, though, that's not automated is that you might have specific agents that you would use to scan and monitor the customer VM and the customer database. So you have to install your own agents. And then the next step is by default, the logging implementation inside of the customer VM is stored locally. A typical thing that you need to do as a customer is to send those logs to your remote security information event management server. Named user authentication, or we use SSH, token-based SSH, to get inside of the VM. When the VM is created, we automatically prompt the customer for a public key that will install to the privileged accounts of the virtual machine. Anyone with access to the private key associated with that public key can log into the VM. The next steps customers usually need to take is either to control that private key through something like CyberArk and manage those keys through something like CyberArk, and then use CyberArk as a privilege access management system to govern access to the VM. And in that model, you would access the VM using a privileged credential, but access to the privileged credential would be controlled by a customer asset. Alternately, you can directly implement named user authentication. So you'll have a customer named user shell into the VM directly, and then use a tool like sudo to gain access to a system account.
So is any of that going to break automation for patching and stuff like that? If you're implementing named user authentication, we want to keep them secure from a database and an infrastructure point of view. So patching is important, security patching especially.
That's actually a really good question. The first step we have up here, you get to set the root password, which also means you become root. Yeah. It is true that if you're root, you can do anything to a system,
you can shoot yourself in the foot, yeah.
Yeah, or the head, right? You do have complete control over the VM, which is nice. The real trick is to understand the architecture of how the automation works. And when you lock the system down, you want to make sure that you permit the automation to function as you desire it to function, which can be completely turned off. And then also to know that disabling the automation doesn't disrupt access to a database. So an important part here is that if you were to update the security model such that it would disrupt the automation. For example, our automation requires token-based SSH in some cases, and we require access to a particular agent on port 443. If you can permit those connections, life is good, the automation will function fine. If you're required to disable those connections, you have to know that the automation will cease to function until you enable it, which might be fine. And that if you take that action, you just need to know that the database connections will still work. So it's really a balance. You might decide that I don't need to patch except once a quarter, or I only am going to apply security fixes on the 15th of every month, and I'm only going to apply them in this 2-hour time window. So what I would like to do is to enable the system to be patched for 2 hours a month, and then make it so the system is impossible to patch, because patching is also a good way to compromise the system.
So, Jeff, we got more than we bargained for. This is great. I love it. The higher level theme that I am hearing in your answers is that there is a side to security when you look at it through the lens of security demanding enterprise requirements. That is its own complex facet, aside from the normal vocabulary of security that anyone who has been interested in security in general is aware of. It is a different discussion than just the tools of protecting access and encrypting data in flight and at rest and so on. It is the interplay with long-term, always-on operations that makes it fascinating on its own accord, I think. So as you are building solutions for customers who have very specific, very high requirements, you don't get to force certain ports have to be open or we take the ball and go home. You have to accommodate customers who refuse to keep some ports open and find the trade-offs that work for them. Is that a reasonable description?
Yeah, but I think you're actually hit it exactly right. Maybe a high-level way is that the nice part about best practices are there are so many to pick from. You should pick the best practices that are right for you.
Bearing in mind that going through the details can only give an impressionistic picture in this context. Tell us a story about something you learned by working with, say, a bank, because that's the part that people cannot see in your slides. Slides always tell the story backwards, right? The story that as it's finished. I think it would be helpful for people to understand why we work the way we work, and also why they can trust us or where they need to challenge us by understanding how we think.
Absolutely. So we'll start with a picture to start the story. The diagram that's up on the screen shows a rough outline of how a cloud service is delivered, and it has 3 important kinds of people that are in the cloud service. One of the first customers I worked with, a defense contractor, and the defense contractor had a FedRAMP high security requirement, and this was in October 2017. So Exadata Cloud customer wasn't a FedRAMP high service. Oracle had not gained that attestation of compliance. So the thing that this guy looked at, he was an innovator, disruptor, and he had an idea of how to deliver cloud for government agencies in the United States typically. And his audacious goal was to be the cloud provider for every 3-letter agency in the United States. And he wanted to host that on Exadata Cloud at Customer because he wanted the automation of Exadata Cloud at Customer and the subscription model. So the cloud delivery model was really, really attractive. And the thing that he taught me was that people are risk. And so the first thing I learned is that there's 3 kinds of people. There's customer people that have a need to access data. These are the people that are typically authorized to access data and are the only ones that have the business of looking at what the data is. There's customer administrative staff that do things like patch and update and such. And the people that patch and update don't have any business looking at the data. And so with the standard model that they had for on-premises deployment is their customer IT infrastructure staff were very select people that were chosen and limited by the customer with very strict controls about how they operated. And because those people were so tightly controlled, they could tolerate the risk of those people accessing their system with privileged credentials. When we moved to the cloud, the struggle that we had is that the Oracle staff member in red, the customer didn't know. And so the first thing that the customer taught us is that the risk of an unknown person accessing my system is very high. And what the customer did is helped Oracle devise an implementation whereby we could take, instead of a large Oracle population, we learned a way to take a small Oracle population and provide the small Oracle population a connection to the customer data center. And instead of doing it through this secure Oracle tunnel, which the customer couldn't see into, we had another box, and the customer taught us to use a customer box over here and then come into our system. And this is all logically blocked out. We don't do this with the Gen 2 control plane. You know, for customers that are looking at this, we as Oracle don't offer the solution anymore because it also has some trouble. But the first aspect was the customer wanted to control how Oracle staff would access the system, which includes limiting the number of staff and controlling the access method in. The next thing that you learn when you go through that exercise is that the discussion of controls is pervasive in every financial services implementation, and it's also very pervasive in, you know, energy utilities and telcos as well, any regulated industry. We had another bank that wanted to look into the isolation. So now we know we have this Oracle person, right, that can access the customer system. The next question was in that isolation bit. And so after these customers would deploy the systems, the next one that they saw is this red person, we've controlled their access. We're pretty sure that we like the way they are controlled going into the infrastructure. We like the encryption controls. Nobody worries that you're going to break encryption, or very few people worry that you're going to break encryption. But there's always this nagging thing of, because your cloud automation can connect to the VM, there's always a possibility that a person could hijack that connection. So that the bit that came out after that was for us to work with customers and teach them how to configure firewalls to selectively block the automation access, because we would block the access of the automation would by design block the use of somebody who would hijack that automation path.
And this goes back to don't trust us. We'll tell you how to block us if you want to block us.
Correct. And so in the narrative, you really get into the business of trying to decide what are the possible access vectors. You know, so if we bring up our network control picture, we have two doors into the customer virtual machine. One is on port 22 via a credential, and one is on port 443 via a different credential. And then we have a door into the control plane server, which is effectively a door into the customer data center. And then we have a few outbound doors, right? Remember, we initiate every TCP connection outbound, so there's never a TCP inbound connection that we have to open up. And then inside of the tunnel is how we establish inbound traffic. So the door in the tunnel, you know, is what we would learn would have a lot of scrutiny. And so then the real question always becomes, as the customer, are you comfortable when Oracle walks through the door at Oracle's discretion, or as the customer, do you need to control when Oracle walks through the door? And so that the whole exercise that we go through is that every month we as Oracle work on the features that we're going to develop and the pieces that we have, and we find ways to control access to these different doors for customers and for Oracle staff. Our current state of the art is that we use firewalls in the operating system to control the doors that access the operating system. And then we have encryption that protects the data once it's leave the operating system. So the shipping state of the art today uses that style of controls. As we're moving forward, we have internally very exciting things at Oracle about how we're providing end-to-end automation to further lock down the doors at all of the points that you see in the diagram. And so, you know, maybe the things that we're learning is that every time we show a door in the system or an access point, if we can establish control of that access point, it lowers the risk of running the system, and it makes it easier for us to use these kinds of cloud environments for sensitive data.
Carlos, go ahead.
Hi, can you hear me?
Yeah, Carlos, you sound great.
Hey, Jeff, thanks. It seems to me there's multiple processes for authentication. Could you go over that process? Because there seems to be obviously some authentication, you know, on the control plane with identity access management over on OCI. Then there seems to be other authentication to be able to access the customer VM. And then there's a third authentication to be able to access the database. Could you go over that process and, where is that authentication controlled? You also mentioned CyberArk. Will the customer control it on-prem? Will it all be done on OCI? Could you go through that process and kind of explain what a typical case would be? And then secondly, from a customer user app authentication, how is that done? And how the authentication, as you mentioned, on the person who's going to go into maintenance or do patching, how that authentication, where is that controlled? Could you go through those steps?
Yeah, absolutely. I appreciate the question. The list is a little long, but let's just walk. I'm going to go counterclockwise around the picture to start with the cloud part and then finish with the app part.
Why don't you rephrase the question before you start, just so everyone is up to speed.
Oh yeah, what we're going to describe is the different identities that perform actions, and then for those identities, how are those identities managed for authentication? When we say authentication, that is the act of proving you are who you say you are. And then we talk about authorizations, we're really talking about, are you allowed to do the thing that you've asked to do? The first place that you have authentication in the system is in an Oracle Cloud tenancy. When you're in an Oracle Cloud tenancy, OCI uses something called IAM, which is Identity and Access Management, and you have a user ID and some sort of secret that will identify you as gavin.parish@oracle.com. Your identity in the customer tenancy permits you to access resources, which we call our DBaaS UI or API, and these allow you to do what we're going to call orchestration. So this orchestration stuff is like creating databases and deleting databases and patching databases. All of that, like database lifecycle management stuff, scaling OCPUs in a cloud infrastructure, that is all handled by your OCI Identity and Access Management credential. Once a command has been authorized, there is a secure connection between the Oracle Cloud and the customer endpoint, which is on our control plane server. And that secure VPN is locked down via certificates that are installed on the control plane server and the Oracle admin VCN. The next identity, if you will, is the identity of the control plane server and how that matches to the Oracle admin VCN. This is a computer identity, right? So we make sure the control plane server is identified to the admin VCN. Once those people agree, the control plane server component is permitted to talk to the admin VCN and vice versa. The next bit of identity that we worry about, number 3, is the mutually authenticated TLS connection that proves the end-to-end mutually authenticated TLS connection that makes it so the agent is identified by the control plane and the control plane is identified by the agent. That's a set of secrets that are controlled through mutually authenticated TLS. Then the last of the software identity controls is that there is a special set of tokens. Sometimes we have to, from the control plane, access on port 22 as SSH to get into the customer VM. There's another identity, number 4, that connects the SSH keys that are permitted to access the customer VM to software that's secured inside of the control plane server. And so when the control plane server goes to perform an action in the VM, like create a grid infrastructure or create a database, patch an operating system, that's identified via a specific set of keys that are controlled, public key in the customer VM and private key secured in the infrastructure. The next set of identities, number 5, is the customer VM has privileged users like OPC or root or Oracle. Those are a public key, private key pair that, for example, our user here that's an admin has the private key that identifies them as the public key that's been installed in the software. So the cloud automation from point 1, your OCI identity will permit you to install your public key inside of the VM. So you use your credential 1 to install your public key, which is credential 5. And if you have that public key, you can shell into the VM as a privileged user. if you like CyberArk to manage that private key, you don't actually have a person who gets to pay attention to that key. You use CyberArk to provide access to that key to a specific individual. But it's that public-private key pair that governs access to the customer VM. And then finally, the last bit, your SQLnet connection to the database is done as a named user to the database. So it's a database credential that gives you access to the database. And one last one, the Oracle database itself is implemented with operating system authentication. So the same private keys you use here, you can also use those same private keys to SQL plus a sysdba to gain access to the operating system. So there's kind of like three things that you as the customer know about. The first thing is your OCI credential. The second thing is the keys you use to gain access on port 22 to the operating system. And then the third credential are the SQLnet connections that you use to gain access to the Oracle database instance on port 1521. Inside of the system, we have software controls that govern the identities of the control plane server. It's a physical piece of equipment that has a special set of certificates that are secured so that our Oracle admin VCN and our control plane server agree that they can trust each other. And then there's the mutually authenticated TLS connection between the software and the cloud orchestration and the connection to the database services agent that runs inside of the VM. So kind of a long answer, but I want to check, did that cover what you were looking for in the question?
Yeah, Jeff, I figured it would be that complex. So yeah.
The trouble, I think, or at least the challenge, maybe the challenge that we have is if we can all learn this block diagram and what the controls are in the diagram, I think it becomes easier. The struggle when you're a customer is that if we just treat it as a black box, the customer becomes very nervous. But when we show the functional block diagram, like every one of these little boxes is a door, right? And what we want to show the customer is here's how you lock that door, and then here's how you unlock that door so that you can get into that part of the house, right? And so we just need to get a lot of practice describing the layout of the house and the locks on the door. Yes, and it is good to know for every door, there's a lock and a camera. And so like in the customer VM, the customer has audit log service in the VM, all the standard Linux audit logs. So there's camera on every door, and every door has a lock that's controlled by a firewall or a credential. And then over in OCI, we have the exact same things. You know, when you ask backup database, are you allowed to do it? Every code path through OCI is governed by the identity access management system. And there are very explicit security lists and rules that you apply to all of these resources. And OCI has comprehensive audit logging. So every door in OCI has a lock, and every door in OCI has a camera. And then finally on the admin, on the inside, all the Oracle doors have cameras and locks too. We don't share those with customers, but should a customer need access to them, we can provide those logs through our security SR process.
On OCI, there's a possibility to do single sign-on. Do you see a use case where, from a customer point of view, the customer user would use single sign-on or with multi-factor, or do you think they would have to still do multiple authentications separately? 100%
customer choice. OCI supports federated identity management and single sign-on stuff. The person who's here, you know, we showed 3 different credentials that person had, but those 3 different credentials could all be managed through a single sign-on process. And it would just be the question of, would the customer want to permit that to happen through their single sign-on process? It's more integration, but it sure makes life easier versus does the customer leave those identity systems separate? But it's all customer configurable.
Yeah, and if they do it separate, where would they manage it? On-prem or on OCI or wherever, right? So yeah, that would be the second question. Okay, thank you very much.
Yeah, I know we're down to our last couple minutes, so any other questions?
There is a general question that you can see there.
Oh, is there a tool you can recommend hardening or penetration testing of Exadata or any other Oracle solution? So I am not in the business of recommending tools. I do know that any customer probably has tools that they prefer to use, and I would certainly suggest customers deferring to the tools that they like to use. In the cloud implementation, there are very specific set of rules regarding penetration and security testing. And so like if you go to our cloud, from Oracle's perspective, all of our stuff is production. So if a customer were to attempt to penetration test into our infrastructure, we as Oracle we'll see that as a real attack. We won't see it as a test attack. And so I think the important part is that we have a set of public rules, like customers can scan anything they want inside of their virtual machines. Like if you have a credential to access it, you can do whatever you want. But if you try to gain access to the infrastructure, that's where Oracle typically won't permit that. And it's because these are all production. And the suggestion we usually give to customers is to divert to Oracle's attestations in terms of what her software does and what the security compliance is.
Thank you, Jeff. That's great. So we are near the end of the hour here. I think that this obviously has much more depth than can be covered here. Hopefully, all of you who attended have gotten a sense that there is a mindset at work here, as represented by the way Jeff explained the solutions. And that mindset is what drives the quality of the security, right? In very high level terms, there is an attention to identifying all the doors and securing them and auditing them, but also an ongoing iterative process of humility to the requirements from the customer, right? So that the trade-off is always the right trade-off of convenience versus security, or flexibility versus security. As you all know, you can follow up with questions. You can ask questions against this session, and Jeff and us will get them. So if you have other questions, do our best to answer them. Anyway, Gavin, you have time for one final question or comment, and then we'll let Jeff close it.
One final question, comment. Security is obviously a very complex thing. From what Jeff's gone through here, we've tried to think from an Oracle perspective through as much of this, and the interaction that Jeff has had with a lot of our on-prem and cloud customers to get it to a point where if there's a door but there's a camera and a key. I think we've done a very good job in terms of securing a cloud infrastructure, and especially a cloud infrastructure that sits behind the additional defense of the customer's network. I think providing a cloud-like solution in that extra defense of their own data center, I think provides a great benefit for getting something like an Exadata, like the performance, the power, the speed of an Exadata, but with that cloud tooling, I think is a really good thing. So I like it, and thank you, Jeff, for spending some time with us today.
Yeah.
And Jeff, but for your closing, here's my half question. Can a high security entity like a bank run these things in production today with the solutions that are there?
Yes, there are banks that run these solutions today. And the solutions today have limited adoption within a bank. So the crown jewels of a bank today are very hard to gain access to in terms of the value of the data. And the bit, I guess, that's here is to answer that question is that, we at Oracle have recognized the market value of putting really comprehensive controls in the systems, as Gavin said, the doors and the locks and the cameras. And that what I'm describing here is really where Oracle's starting from. Our development ideas and the creativity that we have with respect to this industry, and the help that financial services companies and energy utilities and defense contractors are having with Oracle through our partnership, we're figuring out how to use two different corporations to secure mission critical, societal critical data in the world. And we're doing it with two different corporations working together. So what used to be a customer had to keep everything with their own staff in their own walls. And now what we're providing a mechanism is whereby customers can work with the cloud provider, and the list of controls that's here is going to grow significantly as the service develops. And so I think maybe the last bit is, a bank can use it today, but it's a little hard. But we really are learning what banks want, and we're going to make it easier for banks to use the service.
Thank you, that's great. Bringing the ability for two separate complex entities to cooperate on a high complexity solution is really what's probably most fascinating and interesting. And there is a lot of value to be had there because the separation of concerns is the right one. We at Oracle have to worry about the left side of the picture and let the customer to deal with the security only insofar as keeping us honest and monitoring their own actions. But we do the infrastructure and the security that comes with it. So that's great.
One last thing is that, our development team, we have skin in the game. because as far as I know, most of the people at Oracle, our paychecks are deposited into the banks that buy Exadatas. It's really important, right? When we look at this, we really know that this is mission critical infrastructure for real things. I mean, we don't just have a technical problem of like crashing somebody's, social media feed. I mean, we know that we're actually taking care of money. And so we take it really seriously, and it's a really fun place to work.
Certainly gives a lot of meaning to what we do. Jeff, it has been a pleasure as always. Thank you so much. We'll follow up by posting on the same office hours page. And thanks to our audience who stayed past the time. We really appreciate your coming and your questions that are coming are always helpful. So keep coming to these sessions. We really learn a lot from you, and we hope that we make our experts more accessible to you as well.
All right. Thank you, Cris.
Thanks, Jeff.
Thanks, Gavin. Thanks all for coming. I appreciate you having me.